All right. Well, my name is Sean Beckett. I'm the program director over at North Branch Nature Center. If you are new to our Nature Center programming, just want to say welcome and thanks very much for tuning in. If you've been around a while, then welcome back. But it's my pleasure to be able to welcome Doug Facey today and talk a little bit about the aquatic environment and the aquatic residents that we have in our state. I'm guilty of this too. I tend to think a lot more about our terrestrial neighbors. And I think that it's fair to say that our aquatic neighbors are just as fascinating and diverse and amazing, and yet often a lot not as well known. And so it's been a long time coming for us to welcome somebody who knows a thing or two about fish. But first, before we get going, before I give things over to Doug, I just wanted to say a big thank you to our sponsors. I want to thank our lead sponsor, Hunger Mountain Co-op, for making this possible. I also want to thank Onion River Outdoors. I want to thank GreenVest, Capital Copy, and Union Mutual. This Naturalist Journeys Online series couldn't happen without the support of our sponsors. This series is going to be running on most Wednesday nights from here all the way through. We have presentations scheduled all the way out through January. Our next presentation after this is on November 11th, talking all about entomology and particularly macro photography around entomology. The week after that, we have a great presentation on harvesting wild apples. Later in the season, we'll have programs on animal acoustics, on birdsong, on all sorts of things. So please check back on our schedule, northbranchnaturecenter.org/events, to see what else we have going on in our Naturalist Journeys online series. So with that, I want to turn it over to Doug Facey. Doug, thanks so much for joining us and for sharing your wisdom.
Thanks very much, Sean, and thanks for inviting me. It's a pleasure to be here, and I want to take a moment to thank all of you for taking some time out of your busy days to spend some time to hear a little bit about fishes of Vermont. I was wondering if I might see some familiar faces or names, and I see at least one. Judy, hi, how are you? It's nice to see you. And I don't see everybody on the screen, so I'm not sure there may be a few other familiar folks out there.
I forgot to mention too, Doug, we should mention that that folks, please feel free to, and we encourage you to throw any questions you have into the chat bar as we go. And I'll go ahead and moderate those questions, since it's often difficult for a speaker to be able to see the slides and the questions at the same time. So if you have any questions, throw them in the chat bar and we'll kind of take them throughout as we go. Thanks.
Yeah, thanks for adding that in, Sean. That's right. Definitely feel free to put some questions into chat. So I've been fascinated by fishes for a very, very long time. They're an incredibly diverse group of organisms, which is really not surprising if you consider the fact that they've been evolving and diversifying for well over 400 million years, close to 500 million years, actually. And not only that, but our planet is covered mainly with water, and some of it's very, very deep. So there's a huge volume of water out there, and there's a tremendous, tremendous diversity of fishes. Sean mentioned a moment ago that a lot of people tend to focus more on terrestrial organisms, which is understandable because we can see them a lot. But there are more species of fishes than there are of all other vertebrates combined. So if you took all the species of birds, mammals, reptiles, amphibians, added them all together, you still would not have as many species as you have species of fishes. Now, I'm not counting the invertebrates, obviously. That's a whole nother ballgame. But anyway, a little bit about my own personal history. My dad liked to fish just as a recreational activity. I grew up on Long Island, New York. We used to take some family trips up into the lower Adirondacks and spend a few days on a lake here and there. So I got introduced to fishing at a pretty young age. In 1967, we actually took our first trip up to Vermont. Some of you who are old enough may remember something called Expo 67 in Montreal, and that's what drew us up to the northern borders of Vermont on Missisquoi Bay in West Swanton. And so here I am with my brother and sister. We enjoyed our time on Missisquoi Bay so much that we came back for several consecutive years through my high school years. I mentioned I did live on Long Island, so we did get a little bit of offshore fishing every once in a while. So I've got some bluefish here. One of our subsequent trips up to Missisquoi Bay, I think it might have been the last year we were there. As you can see, I got a little bit bigger and the fish got a little bit bigger too as we worked our way through. I really enjoyed my time in Vermont. So after I completed my undergraduate work at the University of Maine in Orono, I came to UVM, where I did my master's degree studying eels on Lake Champlain. And here I am on the edge of Mallett's Bay, actually, at the sandbar launch area. And then after being gone after that from Vermont for about 10 years, where I got my PhD down in Georgia, studying stream fishes in the Southern Appalachians, was very happy to have the opportunity to come back to Vermont once again and be by Lake Champlain by being a faculty member at St. Michael's College, where I've been now for a little bit over 30 years. Brought me back to Missisquoi Bay. I've got a little bowfin over here that we dragged up in a net. And in more recent years, as I've had some time, my wife and I have enjoyed some travels to some tropical areas and down to the Florida Keys, where I've done some snorkeling and some fishing. This is a Goliath grouper, which is one of the largest groupers that we have. It was bigger than me, and it was a little bit, I'm not sure which of us was more curious about the other. It was definitely curious about me, and I was definitely curious about it. So this is a little bonnethead shark, which we threw back shortly thereafter. And as Judy knows, because she knows me, and maybe a few others of you do, I have quite a collection of fish shirts. Here I am wearing one of them. I've got another one on right now, and my artificial background right over here is just a small sample of my closet. So having said that, it's like, okay, yes, I've got fish in my blood all the way through. Let's focus a bit more now on local stuff, fishes of Vermont. We have over 90 species in Vermont, and almost all of them are found in Lake Champlain. So we have most of them here. We do have more freshwater fish species in Vermont than we have in any other New England state by quite a margin. I think the next closest New England state in terms of strictly freshwater fishes is probably around 50 or 55 species, and we've got nearly double that. Again, I'm not counting any of the saltwater species here. The reason for that, if you know anything about the geology of our region, is because during the recession of the glaciers from the last ice age, when the glaciers went down all the way down past Long Island, and we were covered where we are right now in Vermont, covered by over a mile of ice. As that ice melted and receded, there was a period of time where we were connected aquatically to what was referred to as glacial Lake Iroquois, which contains upper New York, basically from the Finger Lakes region all the way up to the Great Lakes, and a whole bunch of stuff further to the west, including parts of the Ohio River Basin and the Mississippi Basin. So we had this aquatic connection for freshwater fishes to move on over. There was also a period of time where they could come through the Mohawk to glacial Lake Albany. So we have picked up some species from this region that never made it any further east. And so we do have some species here in Vermont that you won't find further east from us, unless they've been intentionally stocked over in that area. So this is one reason that we have a lot more species here, freshwater fish-wise, than all of the other New England states. Just recapping a little bit of that, back around 12,500 years ago, this was Lake Vermont. You can see it's also quite a bit larger than our current Lake Champlain. So certainly we had areas like, for example, Mount Philo, if you're familiar with Mount Philo, was an island at that time where the water was high enough that the top of Philo was an island. After the glaciers receded far enough, the St. Lawrence lowlands opened up and we had Atlantic Ocean water rushing in and coming into the valley. So we had a period of brackish water, so it was somewhat salty, which is the Champlain Sea period. And then gradually, as the glaciers continued to recede and melt and the land rebounded a bit and started to come back up after the weight of the glaciers was removed, rather than flowing southward down through the Hudson area through glacial Lake Albany, the flow reversed. And now Lake Champlain flows up through the Richelieu up to the St. Lawrence. And so we became, once again, a totally freshwater body. So that's a little bit about the geology. In terms of the fishes of Champlain, I'm going to focus mainly on them, but then again, almost all of them, almost all the fishes in Vermont are represented in Champlain. We have over 85 species. Last I was aware, there may be some other species that have come in recently. Over 70 of them are native. A couple of them have been extirpated because of a combination of overfishing and habitat destruction. A couple that we're actively trying and have been somewhat successful in reintroducing in recent decades are the lake trout and landlocked Atlantic salmon coming back. We do have several species of endangered or threatened species of fishes in Vermont, including some Brook lampreys, the sturgeon, and a few others that you'll get introduced to as we move further through the talk. We also have some non-native species in Lake Champlain, And the numbers on that seem to be going up periodically. They don't seem to ever go down. Once they get established here, they seem to like Champlain quite a bit. Some of them were brought in intentionally and stocked, like rainbow trout steelhead, which are actually the same species. I'll say a little bit about that later, but they're different ecotypes of the same species. And also brown trout. Brown trout are from Europe, and the rainbows are from the Western United States. But they were brought in to enhance fishing opportunities. We believe that largemouth bass and black crappie may very well have been introduced as well at some time in the past, and they've all become established with their own naturally reproducing populations. Some other species that have come in, blueback herring and alewife, which are two members of the clupiid or the herring family. We've heard a lot about alewife in recent years because they've really taken hold in Lake Champlain, and their numbers have expanded tremendously. Some European introductions like tench and rudd in recent years. European carp we've had around here for quite some time. Carp were brought into the United States from Europe in the probably mid to late 1800s. In the Mississippi drainage, they escaped from a culture pond during a flood, and then the rest is history. They pretty much spread all over the place. And there's a few other species like white perch that have gained entrance, most likely by way of the Champlain Canal that connects us to the upper parts of the Hudson River, and others like bluegill and crappie that have been brought in by various people over the years and have gotten pretty well established. Of the many species that we have in Vermont, there's a good number, I'm guessing at least 15 to 20, that are likely to be sought by people who enjoy fishing as an activity. They would identify those species either as what some people refer to as game fish, which would be things like salmon, lake trout, bass, pike, things that are known for their fighting capabilities. And then also this general category that some people refer to as the so-called panfish, which are smaller fishes that a lot of people like to eat, things like crappie and sunfish and yellow perch and things like that. The rest of the fishes pretty much get ignored, and that includes over 27 different species of minnows of various kinds, and I will not introduce you to all 27 of those, but there's quite a lot of them, most of them being native, and it's just important to remember ecologically that all of these species have a role to play, and they're all important parts of our ecological community. What I'd like to do now is take you on a little bit of a trip, sort of on a systematic level, starting with some of the more primitive species, going up through some of the more advanced species in terms of their evolutionary, the degree of evolutionary change from the ancestors. And that's going to start us with a very primitive group known as the lampreys, which a lot of people I'm sure are familiar with. They have this long eel-like body. They don't have any jaws. They just have a kind of a suction type mouth, at least on the parasitic adults. We have 4 species of lampreys in Vermont, and 2 of them are parasitic, the silver lamprey and the sea lamprey. And we hear a lot about sea lampreys because they do have an impact, negative impact on a lot of our sport fishes. But we also have American brook lampreys and northern brook lampreys, which are non-parasitic lampreys. They're filter feeders. They never get very, very big, but they're very susceptible to the same lampricides, the toxins that are used to knock back populations of sea lampreys. So when sea lamprey treatments are going on, which they literally are, like right now, this past week and this week, I think they're going to treat the Lamoille River this week, I think, or next week sometime soon. And Lewis Creek was done fairly recently, I believe. But anyway, when those toxins are put in the water to knock down the populations of sea lamprey larvae, to knock down sea lamprey populations, these other lampreys are affected as well. And so there's really, unfortunately, this collateral damage of non-target species that do get affected by these chemicals that we put in to control the lamprey population. But lampreys do have a negative impact on sport fishes. This is a lake trout with a couple of lampreys attached to it. And there's no question that lamprey control does reduce populations of lampreys and does reduce rates of the incidence of harm and scarring on these game fish populations that people really work very hard to raise their populations, like lake trout and Atlantic salmon. So I could spend a lot of time on that topic, but I want to move on. Sturgeon are physically the largest species that we have in Lake Champlain. They can get 5 to 6 feet long. They have bony plates under the skin, but a very, very smooth skin, so you don't really feel scales on them, but they have these big bony scutes, this big lopsided tail with a large upper lobe, long snout with barbels that have taste buds on them, and a suction-like mouth that they use to protrude down and suck up food off of the bottom. They are an endangered species. They used to be, historically relatively abundant, and they would migrate up on large rivers like the Winooski, the Lamoille, and all of the big rivers to spawn in the springtime. But they were susceptible to capture. They're slow to mature, so they don't reproduce that rapidly in terms of their life cycles. And they were harvested partly for their meat, which often was smoked, but also for their eggs, which are sold as black caviar. So between the hunting and fishing, or the capture, the harvesting of these fish, and also the loss of spawning habitats, mainly loss of spawning habitats due to dams and rivers that prevent access to good spawning habitat, these populations have dwindled dramatically. But pleased to say that in the last decade or so, there have been significant efforts to protect and keep track of the sturgeons that are out there, and they're back. They are reproducing. It's just that it's a slow process. And there's been some tagging studies to monitor their movement around the lake. And there are sturgeon out there still, and people still do catch them from time to time. If you ever catch one, you should release it immediately, okay? Because they are a protected species, they are endangered. But if you're out there fishing for catfish or something like that, you might catch a small sturgeon. I know there have been some caught in the Winooski River in recent years, for example. So, but just release it. Don't bring it home and take a picture of it. One of the species that I think is among the more interesting, I mean, all of them are interesting, but this is a really neat one, is the Longnose Gar. The Gar family has several representatives up and down the East Coast, all the way from the Gulf of Mexico up to here. But we only have one species here. It's the Longnose Gar. They can get 4 or 5 or more feet long, more commonly not quite that big, with really, really long toothy snout, big jaws, a rather pike-like body, and they have really, really tough scales, much tougher than probably the scales on any other fish that you would encounter in Lake Champlain. If you had a really sharp knife, you'd have a really hard time penetrating the scales of a gar. One of the things I think is interesting about them biologically is they have an air-breathing capability. They have a gas bladder which functions as a lung. They can do very well in warm water that has low oxygen levels. They'll just stick their head up to the surface of the water and gulp some air, and they can get by just fine. I also found that it was interesting that from a translation of Samuel de Champlain's diary, he has a description of a gar, but very specifically, he comments on the great abundance of fish, many varieties, and he points to one, I'm not quite sure of the pronunciation here, shafaru, I'll say, which varies in length, the largest being, as people told me, and these would be the indigenous people who he encountered when he first came into the area, 8 to 10 feet long. He saw some 5 feet long, which that I believe, as large as his thigh, and he describes the snout, 2.5 feet long, very, very sharp, dangerous teeth, and this rather pike-like body, and the scales that are so strong that a dagger could not pierce them. What he is describing is a gar. There's nothing around here that could have that description other than a gar. This particular species of gar is not known to get 8 to 10 feet long. There is a species of gar called the alligator gar down in the Gulf Coast and lower Mississippi drainage, which can get that big, but not this one. So this was either an exaggeration, which, you know, people who catch fish have been known to exaggerate a little bit from time to time, or maybe they just looked that big from a distance, but they weren't really. This description, however, is seen by some people as a possible source of the Champlain monster story. A beast that could be this long with armor-like covering and huge jaws with lots of teeth. And some people kind of wonder if this might have been the origins or the beginnings of some version of Champ, although this clearly is nothing, does not look anything like the more modern ideas of what people have claimed Champ might look like. So, but it does appear in Champlain's diary. Another air-breathing fish that we have that does very well in shallow, warm water where there's not much oxygen is the bowfin. Very stocky body. The males have this eye spot near the tail, often with a little bit of orange or yellow around them. So they're a little bit sexually dimorphic. If you've ever caught one of these, you know they're not easy to catch. They have very bony mouths, but they fight like heck. They're really a fun sport fish, but you should release them. I've never tried to eat one, but I understand that they're not very tasty. So they live in very, very muddy, warm habitats, so I can believe that might not be the best tasting flesh from a fish. A little bit about the minnows, and it'd be easy to talk for a whole hour about minnows because we have so many species of them, but the minnows are a specific family of fishes. Minnows are not just any small fish. Minnows are a particular group with certain characteristics, although they are very varied in their appearances. Some of them, like the golden shiner, are laterally compressed and have a somewhat deep body. Others, like the dace, the black-nosed dace, the long-nosed dace, are a bit more rotund. Creek chub kind of fits that category as well. Some of them are quite small, like the red-bellied dace, which probably doesn't even get more than, say, 4 or 5 inches. Creek chubs could get up to 10 or 12 inches. The carp, which is a non-native minnow introduced from Europe, in Lake Champlain, there are carp there that can easily be 25 or 30 pounds. I mean, they can get really, really large. And I'm sure there are some that are even bigger than that. One of the neat things about the minnows as a group is that during the breeding season, which is typically spring and early summer, the males will get very, very colorful. Like this is a common shiner, which typically is just silvery colored, but during the breeding season, the males take on these really, really brilliant red flush colors around the fins and the belly. Similarly with this red-bellied dace, that they're not colorful like this all year round, but during this breeding season and through much of the summer, they will take on that color. So lots of different minnows out there. The suckers are a group that are closely related to the minnows. So in terms of their overall body shape, they can be quite similar. And in fact, there are some minnows that look a lot like suckers, and there are some suckers that look a lot like minnows. One of the ways to tell them apart is you take a look at the underside of the head of a sucker. You will see very, very thick, fleshy lower lips. And they literally will suck up organic material off the bottom, and that's pretty much what they'll be feeding on. This is one of the red horses from the Missisquoi River. I think it might be the shorthead red horse. They also have a pretty long anal fin, this medial fin here, which you can see reaches back past to the beginning of the tail. Doesn't show up as well in this particular artwork, but you can see it really well in this particular photograph. If you go back to the minnows, minnows have anal fins also, but they don't reach that far back. So there's always a bit of a gap between the anal fin and the tail of a minnow, whereas with a sucker, you'll have an anal fin that literally, if you flatten it out, it will reach all the way back to the tail, in case you're ever wondering. So now you can tell people at your next cocktail party, although, you know, during COVID days, you shouldn't be attending lots of cocktail parties anyway, but you can explain the difference between suckers and minnows, and I'm sure people will appreciate the time that you put into that. A lot of people are familiar with the catfishes as a group. They're pretty distinct in their physical appearance by having those barbels around the chin and the mouth. The very common one that a lot of people catch is the brown bullhead. A lot of people call it the bullpout. Doesn't get too terribly large, but it's a pretty popular fish for catching and eating. We also have yellow bullheads, which are a bit more common in the southern part of the state. They do take on a yellowish greenish color. One thing about them that makes them distinct from the brown bullhead is the chin barbels on the yellow bullhead are white, whereas on a brown bullhead, they're dusky gray or dark or black. So if you're ever curious, there are some other differences too, but that's the easiest way to tell them apart. The stone cat is a very, very small, somewhat compressed catfish that lives in some of our river systems in rocky, riffly areas. It's very secretive. They're not likely to be caught because they're quite small. Places like the rocky areas of the La Platte River or parts of the Missisquoi, but not in the muddy areas in the rapid, kind of in the rapids, hiding in under the rocks. They don't get very, very big. And they kind of squeeze into small, tight places there. They are one of our protected species. The channel catfish is our largest catfish. They can get pretty good size. Here's one that we got in a net some years back. Sometimes people will pull some in for the LCI Derby that'll be up in the 18 to 20 or more pound range. So there are some pretty big channel catfish out there. So that's the biggest of our local catfish. We don't have any of the flatheads or blue catfish that people have in the southern states that can get like 50, 80, 100 pounds. We don't have those in Champlain, but we do have channel cats that can get over 20. So that's a pretty good sized fish. A fish that I have a long affinity for because I studied it for my master's degree when I did my work in Lake Champlain are the eels. Eels have this long body. They do have scales, but the scales are deeply embedded in the skin. So if you ran your hand over the fish, you wouldn't really feel the scales, which is why some people say that they don't have scales because you wouldn't notice them. They do have these front pectoral fins, but they don't have any other fins along, paired fins along the body, except for this long dorsal that kind of goes into the caudal, which is the tail fin, and then up into the anal fin like this. Historically, there are records that the Abenaki used to fish and catch eels quite a lot, and there was a historic fishery in the Richelieu River. And the reason that this was so effective is because eels are migratory, and the eels in Lake Champlain are going through this sort of adolescent growth phase. They actually began as juveniles, as larvae, in eggs in the Sargasso Sea. That's where these eels lay their eggs. And they hatch out into a very clear, something known as a leptocephalus larvae. They drift by ocean currents up along the coast. They transform into an actively swimming glass eel, which is still transparent. And they'll be gathering along the coastline as glass eels. And then they gradually develop coloration, start migrating inland. Some of them will stay in estuaries and relatively close to the coast. Others will move very far inland, all the way up the Mississippi, all the way in the St. Lawrence, all the way to the Great Lakes, all the way down the Richelieu and into Lake Champlain. It probably takes them a few years to make that journey. And then once they're established, they'll stay here for a long time. When I did my master's work in Lake Champlain, we had eels commonly in the 15 to 18 year range, sometimes even over that, sometimes getting close to 20 years old. But at some point, when it's time for them to reproduce, they will migrate out. And the way to get out of Lake Champlain is to go out the Richelieu River. And there had been a very active commercial fishery for eels along the Richelieu for many, many, many years. And so this was an important part of the Richelieu region economy for quite some time, especially in the fall when the eels are making their run out. Now, what gradually happened over the years is the fish used to have pretty easy access by following that waterway all the way up into Lake Champlain. But gradually, the old wooden dams that were always pretty leaky and partly falling apart, which the young eels could get by pretty easily. When those started to get replaced in the 1960s and 70s and 80s, and they got replaced by concrete structures, basically the pathway for these young fish pretty much got shut down. And so the eels in Lake Champlain, we still have them, but their numbers have diminished considerably. Canadian government put some time and money some years back into trying to restock them, to bring elvers from the coast, some of these young elvers and these glass eels, and literally put them into the Richelieu on the Canadian side of the border. But the expectation is that the fish would move into Lake Champlain and eventually start coming back out. But eels, for a lot of different reasons globally, have been having a really, really tough time in the last couple of decades. A lot of it probably has to do with eels all over the world have the same basic life cycle. They don't all come to the Sargasso Sea, but they do go out to the oceans. They come back into the river systems, and of course our river systems are far more polluted now, although they're less polluted now than they were maybe 30 or 40 years ago, but still they're a lot worse off now than they were back in the 17 and 1800s or before that. So a lot of these eels, because they live for a long time and they eat a lot of benthic food, they accumulate toxins if there are toxins in the environment, and that has probably had some sort of an impact on them. So, but anyway, the eels are a popular commercial fish for parts of Europe and Asia. So there is commercial fishery, and there's actually an economy that some of the Asian countries like Japan, for example, will buy glass eels captured from the Gulf of Maine and Nova Scotia and have them shipped over so they can raise them in aquaculture facilities to provide eels for their food industry, because they're a very popular fish for a lot of people. Not quite so popular here in the United States, however. Moving on to another family, the clupeids, the herrings. The herrings you might recognize as basically a marine family, herring and anchovies and things like that. We do have shad in the Connecticut River, and before all the dams were put along the Connecticut River, shad used to run all the way up between Vermont and New Hampshire, way up into the headwater areas, but that's no longer the case because of all the dams that are in place. So we haven't had good shad runs in Connecticut for quite some time. We have had alewife and blueback herring, non-native, getting into Lake Champlain. We think the bluebacks, which never seem to really take hold, they may have come in through the Champlain Canal. But some years ago, alewife started to really explode in Lake Champlain. We suspect, I don't know for sure, but there's a suspicion that they may have been brought in as a bait fish and then released at the end of the day, sort of a bait fish introduction. People sometimes do this. This is one reason that Vermont, among other states, has put much tighter restrictions on the use of bait fish. You should only use bait fish that actually come from the body of water that you're fishing in. And at the end of the day, they don't want you to release any unused bait fish. They'd rather you throw them in the bushes or kill them or toss them aside somehow. But there is this unfortunate tendency to release some of these fishes, which in some cases are non-native, and then they kind of take over. Alewife are voracious filter feeders, and they feed in the deep areas, the open areas of Lake Champlain, and compete with a lot of our native species. And one of the interesting and troublesome things about alewife is they often contain an enzyme known as thiaminase. And what thiaminase does is the predators that feed on the alewife, which include things like lake trout and salmon, they pick up the thiaminase, and the thiaminase is an enzyme that breaks down the B vitamin known as thiamine. And that means that the eggs that are produced by the salmon that have been eating the alewife are short on thiamine. What that means is when the juveniles hatch, their mitochondria, their cellular structure isn't well designed for success. And it can lead to a situation known as early mortality syndrome, a high level of mortality among the eggs and the newly hatched young. Now, the good news is that since this has been recognized as a problem, it can be treated. And if we know that that's a situation, and our fish hatchery people will be keeping track of this, they will often treat the water with enhanced levels of thiamine so that the developing eggs and larvae will get the thiamine that they need and will not die. Just literally, they die running out of energy because of the important role that thiamine plays in cellular structure or infrastructure. So having said a little bit about salmon, let me move on to the salmonids, which are the trouts and the salmons. I think most people would recognize some of our common local species like the brook trout and the lake trout. And these are two of our natives that are in the so-called char group, the genus Salvelinus. Here's a lovely lake trout. It was brought in from, let's see, that was 2009, the LCI Derby. Just under 16 pounds, so they can get pretty good size. They have this little adipose tab fin on the back. Nobody seems to really understand exactly what it's for, but it is one of the characteristics of a few of our families, including the salmonids, but there's a few others that have that as well. But these are native species to Vermont. And as I mentioned before, the lake trout had been extirpated, but people were bringing it back with some success, which is good. A lot of our native brook trout populations have also been taken out, but they are being reintroduced by stocking. But we want to be careful about the stocking source because you want to use fishes that are well suited for the local conditions. Probably one of the most well-known of our salmonids in Lake Champlain and in New England in general is the landlocked salmon, or if you're in a coastal area, basically the Atlantic salmon that are not landlocked. Landlocked salmon are native to Lake Champlain. There are some historical records that suggest that we may have actually had sea-run salmon at some time in the distant past, coming all the way in St. Lawrence, down the Richelieu and into Lake Champlain. And the reason I say that is because some of the records from way back when talk about salmon that are frankly just too big to probably be landlocked salmon. They probably would have been sea-run salmon, but we don't know for sure, but there is some suspicion that we may have had some sea-run salmon at one time. A lot of people are pretty familiar with the salmon life cycle. They need very, very clean water and gravel to spawn. The eggs are laid in the gravel. And one of the reasons that it's so important that they have good, clean water is that the eggs are buried to be protected and held in place, but you need to have good infiltration of oxygen to get down to the eggs. And if you're in a place where there's been a lot of siltation, a lot of sand, a lot of runoff from the banks, where there's been a lot of deforestation or a lot of land use that adds sediment to the water, these eggs will often just get coated and then they'll suffocate and die. They need really, really good oxygenation. But if they make it to that point, they'll come up as these sac fry, these alevins. They'll start swimming around. They get a little bit bigger. They're kind of darker colored. They blend in with the surroundings of the rocks and the gravel in the stream. And then at some point after a couple of years, they begin to change physiologically into a downstream migrating phase known as the smolt. They get very silvery. and then they move into either the ocean, if it's a river that runs into the ocean, or in the case of Lake Champlain, they'll move into the lake where they will gradually grow for a couple of years, become an adult, and then move back upstream to spawn, and they'll just keep continuing this cycle. One of the really fascinating things that I learned about salmon years ago, and it's just sort of piqued my interest in fishes overall, was the way that they can find their way back to their home stream is very often based on the odors that they basically imprint the memory of these odors from their home stream when they go through this particular phase of their lives. As they transition from a par to a smolt, they basically imprint the smell of home, and then they can find that later on in life when they come back. Now, that only works from within the river system. They don't come all the way back from the ocean to their home stream by smell. They have other mechanisms to get to the right river system. But once they're in the river system, they pick up the scent of that home stream and they follow it back home. Now, the interesting thing about this is that we have a lot of hatcheries, which are really enhancing our salmon populations a lot. But in hatchery conditions, the fish grow pretty fast, and that's intentional so that they can be stocked back out at a reasonable time. And in some cases, the fish will be stocked as fry, and they'll go through this phase in a stream. And if they're successful, then there's a pretty good chance they'll come back to that home stream when they want to reproduce. However, in some cases, fish are held from the par phase through the smolt phase in the hatchery, and then they're stocked as smolts. And what happens then is the hatchery is their smell of home. And so what they will often do is when it's time to come back and spawn, they will come back to the hatchery because that is the smell that they recognize as their home stream. And there's a really good example of that. Actually, before I get to that example, we have ongoing, and it's usually active this time of year. If you're familiar with the hydroelectric dam in Winooski 1, there's a fish lift on that dam. And this time of year, in the spring and in the fall, they monitor that lift for, there's a fish lift on the dam. I'll explain it in just a minute. And they'll bring fish through, and these are migratory salmon, in some cases steelhead, that are on their way back up the Winooski River to spawn. Now, if you ever walk down onto the dam, and you are allowed to go down there, by the way, just don't mess around with any of the equipment. But you look over the side of the dam, and there's a chute down below where water is coming out. That rapid flow of water attracts the fish in to essentially a trap. And that trap is essentially this thing that kind of almost looks like a bit of a dumpster with a lid on it. And they call it the hopper. And then during the migration time, like at this time of year, this will be checked a few times a week. And this big powerful winch will lift this hopper up with, many gallons, a couple hundred gallons of water and whatever fish are in there. And they'll tip it into this holding bin over here. And then our biologists, like Nick Stats in this picture right here, will come in and they'll weigh and measure. They'll take scale samples so they can estimate age. They take a fin clip so they can analyze the DNA, so they can tell which genetic strain it's from, so they can tell which strains are doing better than others in our restocking efforts. And then they'll put them in a truck and bring them back upstream, further upstream to release, or they may bring them to the hatchery to use as broodstock. For fishes that are actually in Lake Champlain and aren't sure where to go, where a lot of them end up going is to Hatchery Brook, which is the outlet of the fish hatchery by the ferry on Grand Isle. And if any of you have ever been to the Ed Weed Hatchery on Grand Isle, and it is open to the public, by the way, so you can go by and take a look, the water coming out of the hatchery, and all the fish are raised indoors, but the water coming out of there goes into a settling pond before it is released down this brook, and then goes down into Lake Champlain right alongside where the ferry dock is. And what that means is that for a lot of fish in Lake Champlain, especially if they were released as smolts, they pick up the smell of the hatchery water, and they come back to this stream at this time of year. So right now, and later even in November is a good time to see that. So here's a little video I took when I was there with a class. Here's Route 314, just up here, just out of view is a little parking area right next to where the actual ferry access is. This is the culvert coming under, and as I play this, you'll see all these fish down here. There's a nice little viewing platform over here. And as I move this around, these are all salmon in here that are just, there's lots of them there that came up this short bit of stream, and they're kind of holding right in here under this water. There's even more of them under here because it's really well oxygenated. And if you stand there long enough, you may see a couple take the hop over this lip and then head up through the culvert and on up into the stream. A really good time to do this is actually a little bit later into November, because the biologists will stop taking the fish out from upstream and they kind of start to stockpile down in here. So what I want to show you on the next slide is a couple years ago, I put some waders on and took a GoPro camera on a stick and I waded into this and just took a little walk around. Some of these fish do get a little beat up. Their fins get a little tattered by all the work that they have to put in coming into this narrow stream. So now I'm walking over to where that really rapid flow of water is. And you can see all these fish stacked up in here. Many of them have tags on them, waiting for an opportunity or just catching their breath before they take a leap over that little bit of a dam there. So here's the culvert just over here to the right. If you walk across the road and walk upstream towards where the outlet of the pond is, you'll see this brook. And if you go along here, you'll see like right there, that was a salmon right there. All these little things that are sticking up here, these little tags, look like little flags. These are all dorsal fins and the upper parts of the tails of the fish that are backed up in here, because there's one right there. Here's one over here. Here's one over here. Because it's very, very shallow in here. You can see that was a tail right over there. And so you can kind of walk right along there and you can see all these fish stacked up, because they can't get too much further, because right up above them where they are, there is a trap. And some of them will enter the trap, but at some point later in November, they'll shut the trap down because they've stopped their trapping. They have all the fish that they need. And these fish really start to pile up in large numbers. Eventually, they'll either spawn right there or they will just turn around and head back out to the lake. So you don't have to worry about them being harmed by this, but it's a neat place to go if you're interested in a weekend field trip in November, to go up near the you can walk around parts of the hatchery as well, but take a look down by the brook and down by the outlet and you'll see where some of these fish hang in. When they get all the way up, here's the trap looking down from above. It's covered with a grate. The grate has been lifted so the biologists can get in there to scoop the fish out. So these are all Atlantic salmon. There might be some steelhead mixed in here too, but they're mostly Atlantic salmon that have come up in here and they're waiting to be processed. So they'll be lifted out, they'll be tagged, they'll be measured and weighed, and then they'll either be brought to the hatchery or they'll be released back out into the lake. So salmon always tend to fascinate a lot of people. So I threw in a few more pictures on a little
Doug,
more.
a couple of questions if I might
Yeah.
jump. Chris is wondering if there's evidence of historical Atlantic salmon runs up the Connecticut River into Vermont.
You know, I can't cite it right off the top of my head, but I have no reason to believe that there wouldn't be. I mean, if you eliminate all the dams, there's no reason. I mean, shad were making it all the way up here, so salmon should have been making it all the way up here as well. I could not cite a source for that, but I'm quite sure that they must have been. Because rivers in Maine, all over the East Coast, before people started putting dams in the rivers, there were salmon coming all the way up. As far down as the Connecticut and Long Island Sound. There weren't many salmon going much further south than that, but they were definitely coming up in there. So.
Thanks. And then we have another question kind of about fish distribution geography. So are there any fish that are only in the Connecticut River, Lake Magog, that side of things, in those watersheds in Vermont, or is the Champlain the main watershed for diversity in Vermont?
There are, well, I mentioned shad as one example of a Connecticut River species that does not appear over on the Champlain side. And I have to admit, I'm not as familiar with the Connecticut, obviously. Otherwise I would have put more explicit mention of it in there. But I imagine that there probably are, but I don't know for sure other than shad. That's the one I can think of. As far as the Magog area, I'm not aware of species that are there that are not found elsewhere in Vermont or over in the Champlain side, but that doesn't mean that there aren't any. So sorry, I just don't know. I don't know much about Magog, to be honest with you. So.
All right, thanks. There's a couple other questions, but we'll hold off until a little bit later for those.
Okay. So I've been talking about the salmonids as a group, and I did want to point out that we do have some non-native salmonids that have been stocked aggressively, and some still being stocked, at least sometimes on the New York side of the lake, but they the fish don't know where the borderline is. And these include the rainbow trout from the Western US and also the brown trout from Europe. And I mentioned earlier that the larger version of the rainbow is the steelhead, and it grows bigger because it takes a migratory lifestyle. Basically, it goes out to the lake and feeds, or in coastal waters, it'll go out to the ocean and feed and then come back in. But these are fishes that, even though they're non-native, they were brought in intentionally to enhance fishing opportunities. And stocking does continue for those. So, people sometimes think about non-natives as being something that we don't want, but fish management does dictate, I shouldn't say dictate, but fish management over the years has created situations where the public asks for more fishing opportunities, more types of fish. One of the reasons for this is that the rainbow and the brown are a little tougher in terms of water temperature than brook trout are. So streams that maybe used to be able to support brook trout 100 years ago because of good forest cover and cooler water, if they can no longer support good brook trout populations, they probably have a chance of supporting rainbow trout and brown trout populations. So by putting rainbows or browns into a river, you are basically providing another species to sort of fill the trout niche into a stream that has lost its ability to support brook trout. The downside is that sometimes there still are brook trout in some of those streams, especially further upstream. And brown trout and rainbows, because they're bigger and more aggressive, will displace brook trout. So we've introduced a species that's actually not working in some cases, not working to the benefit of our native species. But we have introduced other fishing opportunities for people. And that's, fish management is a lot about managing the people and their expectations. It's not just about managing the species of fishes. So, and that's the way fish and wildlife management frequently is, because it's supported by licensed sales and taxpayer dollars. And so when people say they want something, there's a strong tendency for the providers within reason to provide that. The other thing is that if we go back historically, people used to have a very different approach towards stocking, say 50, 100 years ago, or even 30 or 40 years ago, than many people have today. But a lot of these species, once they've been stocked, they start naturally reproducing on their own. So even if you stop stocking them, they're still well established in those streams. So you really can't get rid of them very easily. So moving into the deep water portions of some of our bigger lakes, Champlain being one, but Memphremagog certainly another, and some of our other deep lakes. We have smelt, which are kind of salmon-like in a little bit of an appearance, but they're long and thin. They do have that adipose fin. They are a very important forage fish. They're a fish that feeds a lot of other fishes. They don't get very big. They're a very popular fish to catch through the ice in the wintertime. And they probably average somewhere in that like 6, 7, 8 inch range, although I have seen some around 12 to 13 inches long, but that's pretty rare. You can actually get them that big. But they're often migratory in coastal rivers and streams. So places in Maine, for example, you'll have smelt runs where the smelt come in from the ocean, they spawn, and then they go back out. Or you'll see that in a lot of lake situations as well. But they're a completely different family, but they are an important food base for many other species. Alewife, when alewife got into Lake Champlain, it's been concerned that they may be competing with smelt because both of them feed on not exactly the same food sources, but there's some overlap in their food sources. So, the pike family is a real popular one for people who like to go fishing. The chain pickerel is pretty popular, so is the northern pike. We do have a few redfin pickerel in some of our small marshy bodies of water in southern Vermont, but they rarely get more than 10 or 12 inches long. That's an adult, so they're really, you really have to look for the reddish fins on them, so they're not very common. But the pickerel, the pike, and then of course the muskie is the largest, the muscalline is the largest of the family, are all quite popular. There historically had been a muskie population in the Missisquoi Bay and the Missisquoi River. That population was lost some years ago. It's believed that an industrial chemical spill may have been the problem there. But they've been reintroduced into the Missisquoi. I don't know if they've taken hold in recent years. I don't know if Sean Good's on this call or not, but if he's there, maybe he can fill us in there. They also were stocked successfully in places over in New York State, in some of the rivers that feed Lake Champlain on the New York side. And they are a valuable sport fish. They get big and they fight hard. And this guy was real happy back in 2005 to bring in this muskie that weighed over 38 pounds out of the Missisquoi River. So that was a nice catch. So you can see they're pretty handsome fish, pretty big. So another deep water fish that's interesting because it's a member of another marine family is the burbot, which is a cod. We hear a lot about cod from the oceans and hake and haddock and some of the related species of that family. But we've got one right in Lake Champlain and some of the large rivers that feed the lake as well. It's called the burbot. It's the only freshwater member of the cod family, but it does exist and they can get pretty good size. You would catch them probably bottom fishing deep water, like if you're going for lake trout or something like that in some places. I've always had a high affinity for sculpins. They don't get very big. 4 or 5 inches is a big sculpin, but they're found in a lot of our rivers and streams. They need cold water, so they need high oxygen levels. They hide in the rocks and the gravel. They eat mainly aquatic insects. Very cryptic. They blend in really well, but they're also a good food source for bigger fish. And if any of you are fly anglers and you like to go fly fishing, you may know that there's a wet fly that's referred to as the muddler minnow. This design of the wet fly because it doesn't float at the surface and it's actually designed to sink towards the bottom, has been designed specifically to resemble a sculpin. You can look at the broad head, the mottled coloration over here, and when it gets wet and all these feathers lay down, it looks a lot like that. And a big brown trout or rainbow would probably love to have that. So people who fly fish, if they're using wet flies, will often use a muddler minnow in places where sculpin are found. White perch had become really widespread in Lake Champlain. Back in the 80s and early 90s, they were only in the southern part of the lake where it's very warm and murky, but they do really well under those conditions. They're aggressive filter feeders, but they eat pretty much anything. But they've spread northward all the way up to Missisquoi Bay. And they now are in some of the shallow, warmer parts of the lake, one of the most abundant species that we have out there. They're not native, but I don't think they were intentionally introduced. I think they probably just got in by the connection through the Champlain Canal that connects us to the Hudson River, the upper Hudson. And that's probably why they first started appearing in the southern part of the lake and then gradually made their way northward. They're the same members of the same family as the striped bass, which gets quite a bit larger. Or if any of you have ever fished in the south, like Tennessee River area, you may have encountered yellow bass or white bass. They look an awful lot like this. All 4 of them are in the same family, but the striped bass is the one that gets big. Sunfish is very popular for a lot of kids, especially, your first fishing experience for me was catching pumpkin seeds off a dock in the Adirondacks and then in Missisquoi Bay a little bit later. We also have the bluegill, which has become, in my view, a good bit more abundant in Champlain than it used to be. I remember historically catching lots of pumpkin seeds and very few bluegills. And now when I go out fishing, it's not uncommon for me to hit places where I catch more bluegills than pumpkin seeds. So I think this may be a climate change situation. I'm not sure. They're a little bit further south in their distribution, but we still have pumpkin seeds around as well. Black crappie, rock bass are other pretty popular members of this group. And then probably the most popular members of this family, the sunfish family, is a smallmouth bass and a largemouth bass. Smallmouths tend to be in somewhat cooler water with rockier substrates. Largemouths, somewhat warmer water, often in weedy areas, although not exclusively. And if you're unclear about the difference between them, the name tells it all, smallmouth versus largemouth. In a smallmouth bass, the back corner of the mouth rarely goes back beyond about the middle of the eye. That's where the maxillary bone ends. In a largemouth bass, the back corner of the mouth goes well behind the back portion of the eye. This is not always obvious when they're juveniles, but by the time they're adults, it shows up pretty well. Coloration patterns are often a good clue as well. Getting pretty close to the end here, perches and darters, another popular group, the yellow perch. Oh gosh, I didn't realize I'm close to 6 o'clock already. So yellow perch, very popular panfish. All times of year, people get them and they can get them through ice fishing. Walleye used to be pretty abundant in parts of the lake. Their numbers have dropped off, but there are some stocking programs in place to get them back into the area. And then we have the darters, which are very, very small members of this same family that pretty much tend to dwell along the bottom. And so I won't go into any details on those. Speaking of bottom feeders, here's another member of a marine family. It's another, I think, the only freshwater species of that family. The family is the drum family, the Cyanidae, and this one is the freshwater drum, more commonly known locally as the sheep's head, which has a pretty distinct body shape. Its deepest part of the body is like right behind the head, as opposed to like in a larger smallmouth bass, the deeper part of the body would be back about here. But the drums have a broad area right about there, and then they start to taper down. You can tell by the mouth that it's really well designed for bottom feeding. They'll eat a lot of mussels. They crunch up mussels, the freshwater mussels and clams, and they have really tough teeth deep in their throat that they use for crushing up those shells. I knew I wouldn't have time to get to everybody, so I just wanted to give a shout out to a few of the other families that I didn't have time to get to. I did talk about the salmonids as a family, but I didn't have time to talk specifically about Cisco or lake whitefish, but they're also important members of the communities of a lot of our larger lakes. The central mud minnow, which is related to the pikes, but it's one of those western species that's kind of made it over into the Champlain Basin. Trout perch, killifish, silversides, which the silversides are an introduced species. They probably got brought in because somebody thought they were minnows, and they're not, but you see them around. But I would not call them invasive because the populations have not exploded in a way that affects a lot of other species, but they are definitely non-native. And sticklebacks, which are pretty easy to tell because they have these individual spines along the back. These are a native species, the Brook stickleback. And because I teach for a living, I had to give a quiz at the end. So, but maybe we'll just leave this and because we're pretty much out of time. And I apologize for running a little bit long there, but I'll stop there. And if anybody has any questions, or Sean, since you're moderating, if you've got some questions you'd like to bring to me, I'll be happy to address them. So thanks very much for your time, everyone. I appreciate it. It's always fun to talk about fishes.
Thanks, Doug, so much. I know some people have to run, so before we jump into some of the other questions, I just wanted to give another final thank you to, well, all of you, of course, and to Doug, but I also want to thank our sponsors, Hunger Mountain Co-op, Union Mutual, Onion River Outdoor, Capital Copy, and GreenVest. Doug, there's a lot of folks saying thank you, so that's great. Let it be known. My pleasure. So let me just scroll up. Yeah, Matt is wondering what causes the yearly spring die-off of alewives and smelt that wash up on the shores of Lake Champlain?
Yeah, that's a great one. Alewives are not known for their cold hardiness. And some years the populations just get really, really big. And the way it's been explained to me is they just can't take, in some cases, they can't take the sudden shock. And the typical, what often happens too with a lot of fishes over the winter time is they may die at some point during the winter, because when the ice forms over certain parts of the lake, because some years it goes over the entire lake, but when the ice forms over parts of the lake, it obviously shuts off the interaction between the water and the atmosphere above it. And if it's in a shallow area where there's a lot of decomposition, you can run out of oxygen. This happens in a lot of small ponds. But what happens is if the ice is formed, the fish are dying, but you don't see them. And then when the ice goes out in the spring, a lot of fish that might have died throughout the course of the winter and floated up and got caught by the ice, now the ice is breaking up, and it seems like, oh my gosh, all of a sudden a lot of fish have died all at once, when in fact a lot of those fish probably died a couple of months earlier, and they've just been held in place by the ice, and now they're being released. That's part of the explanation for these large numbers of fish that wash up after the ice goes out. But the other thing is they are, some of them just really are sensitive to temperature. I mean, one reason that we probably did not have successful invasion of alewives and blueback herrings in the past was because it was a little bit too cold for them. But now with climate change, the waters are warmer. Our falls are longer, the winters are shorter, the water isn't as cold. And we have species now that are making it into Champlain and other lakes that did not used to be able to tolerate it. But if they hit a really tough cold snap, they'll pay the price for it. So.
Thanks. So I guess here, this is a question for me. I will invite folks to please go ahead and throw any other questions that they have into the chat bar. Now is your chance. But let's say, you know, for somebody who doesn't have a lot of experience looking at fish, you know, take the example of birds, for instance. If I'm looking at a bird, you know, and I'm trying to teach somebody what to pay attention to on a bird so that they can go and look it up later and have a reasonable chance of actually figuring it out. And I might say,
Yeah.
okay, look for wing bars, look for an eye ring, look for this, you know, half a dozen set of things. Pay attention to these parts of the animal, and that'll be what you need to know to figure it out later. Is there an analog to fish? Like what things?
Yeah, there is, and I've got some experience with birds myself. I know exactly what you mean. There's a tendency when you're looking through the binoculars at a bird, you just sort of look. For a lot of people, if they don't know what to look for, they just look at the bird. But if you only get a fleeting look at it, you want to get a really quick glance. So yeah, I mean, if I go back to see a couple of examples. So for example, you know, what's the overall body shape? You know, is it kind of roundish? Is it compressed from side to side? Is it flat? If you get it in your hand and you can, or get close enough to take a good look, does it have spines in its fins, or does it not have spines in its fins? Where are the fins? Are the fins way towards the back, like you have in a pike? Do they have an adipose fin or not? There's only 4 or 5 families of fishes in Vermont that actually have an adipose fin. There are some that are really obvious for a lot of people. I mean, for example, I think a catfish, you might not know the species, but there aren't many other things that look like a catfish. But still, you know, does it have barbels around its face? But for, you know, getting to the species level, I mean, if you caught a sunfish, but you didn't know what sunfish it was, then you really do need to start paying attention to more specific color patterns. So like for the pumpkin seed, is there a little red spot on that opercular tab, which would indicate that it's a pumpkin seed, as opposed to a bluegill, which does not have the little red spot there. However, we have other sunfishes in Vermont, like the red ear sunfish, which is more common south of us, that also has a little red spot over there. And then, you know, we have some that have longer tabs over here. So, you know, if you can get a picture of it, you know, if you get it in your hand, get a picture of it, then you can go online and somebody can probably identify it for you. But if you're only looking at it, like you get a glance at it in the water, what's the overall size, the overall shape, and what are the fin patterns like? And can you tell, do they have spines or not? So like a lot of our evolutionarily more advanced fishes do have spines. That's why they came near the end of this presentation, which was kind of taxonomically organized. The fishes that came early were the fishes that don't have spines. The fishes that came later are the ones that do have spines. They also have different types of scales, but I won't get into that because that's not going to help somebody who's trying to identify a fish. So, but yeah, I think that would be, you know, getting to Sean's question, I think those are the kinds of things. Does it have obvious markings? I mean, yellow perch have pretty obvious markings on them. There aren't many things that would look like that also have spines. Okay, this particular artwork here does not do justice to the bright orange, colorful fins that most yellow perch actually have. This is kind of a dull image right here, but anyway, that's somewhat helpful, I guess. I hope that's helpful.
Wondering if there's other clues on a fish too, and I just really want to use the phrase red herring more than anything. Are there any red herrings in that? Like something like, you know, I see it has spots or I see it has stripes, but it might be something that is actually really variable between individuals or between populations and is not a good diagnostic for a fish?
Let's see. I'm trying to think if there's anything that can really throw people off if you run. I mean, there are some fishes like in this group here, the trout perch, which I know is very small in this image over here. One of the reasons it was called, my understanding of the naming of the species as trout perch is because it looks kind of like something between a trout and a perch. It's not the result of a trout and a perch crossbreeding, okay? It's its own species. But it has an adipose fin back here, which is a trout-like characteristic, although it's also found in smelt and it's also found in catfishes. But if you look at the front half of the fish with the somewhat large head and the somewhat protractile mouth, it looks a bit like a perch. So if it wasn't for that adipose fin, it would look a lot like a perch. but not a yellow perch, but just sort of a member of the perch family. But it doesn't have spines, and perches have spines. So it's like, well, it kind of looks a little bit like a trout, and it kind of looks a little bit like a perch. So I think we'll call it a trout perch. I'm not sure if that's exactly what was going through people's minds, because I'm not the one who named it, but that's pretty much what I was told quite some years ago. But I'm trying to think if there's something that could really, really throw you off. And well, I mean, I guess one thing, just to be honest with you, is that fish do hybridize on occasions. And so you might actually see something that doesn't quite look the way you think it should. And it might be because it's a hybrid. I mean, the pike family, for example, does sometimes hybridize. So you could get something that's, you know, something between a northern pike and a muskie, for example. I think it's called a tiger muskie is what a lot of people refer to it. So it wouldn't be quite one or the other, but, you know, and the other thing is when pike are small, they look a lot alike. So a young pickerel and a young northern pike look quite similar to one another. So, but that still doesn't really, I don't think that really answers your question exactly. So.
No, that's helpful. Thanks. Matt, changing gears, Matt is asking, he says, there were some fish that were dying and washing up in Burlington a few years ago. Did they ever figure out the cause?
I don't recall a specific incident and what time of year it was. So I'm afraid even though I've been living in Burlington for a long time, I don't remember. But if it was a springtime ice out thing, then what I said earlier may have been the reason for that. But if it wasn't, it was at a different time of year, I don't know.
Matt, if you're out there still, you're welcome to pop on your microphone and add some context to that question if you'd like. And then meanwhile, if anyone else has any other questions, now would be a good time to throw them into the chat before we wrap things up. All right, well, Doug, thank you so much. We really appreciate your time and your expertise here. I've learned a ton, and I hope others have as well. It's a pleasure to welcome you, at least virtually, to the Nature Center, and hopefully we can have you back in real life over here in Montpelier next year.
I'd welcome the opportunity if we, I shouldn't say if, but when we get to the point where we can physically get back together, I'd love to come over and visit sometime. And I've got some, I mean, this, you know, I was asked in sort of the broad sense, fishes of Vermont, but, you know, there are other more specific kinds of things that I could address in a more narrowly focused kind of presentation, such as particular research projects that I've been involved with and things like that over the years. But I think I tried to maybe cover a little bit too much in this talk, but that's okay. So hopefully people.
I think, you know, when learning from a natural history perspective, when you're learning a new taxon, whether it's insects or birds or fish, I think getting a sense of the scope of what your possibilities are is a really important place to start, so that when you look, for instance, at a fish, you know, okay, I have 90 choices. I don't have 900 choices. That's helpful to know. You know. Alana wants to know the answer to that first question on your quiz.
I'm trying to remember what the first question was. I have to go back. Oh, why are there so many more freshwater fishes in Vermont than in the rest of New England? I think that was the first one. And that's because of this. I've mentioned it very early in the talk, and that was during as the last glacial period was ending, we had this historic freshwater connection to what has become the Great Lakes up in Ohio and Mississippi. So we have some species that made it over here that never got any further east. The eastern sand darters, actually, I did some work with eastern sand darters some years ago, and that's actually an example of one of these. The sand darters as a group, the genus Amicrypta, is more typical in the Ohio River drainage and down into the Mississippi. There are the specific species, eastern sand darter, is in some of the tributaries of Lake Ontario. It makes it up across parts of the St. Lawrence. It's in Lake Champlain. And a little bit further up the St. Lawrence in the Three Rivers area, as you move up towards Quebec, it's been found up there as well. But to my knowledge, it has never been found in any other part of the New England states other than in Vermont. Of course, New York is technically not a New England state, but it's in there. So it's literally St. Lawrence drainage, which includes Lake Champlain, and then further westward and southward. So that's an example of a fish that is rare here. And one of the reasons it's rare here is because we are at the very edge of its range. So it's much more common in other places.
We have one more question, although, oh, let's see here. So Matt is clarifying his question from earlier about that Burlington waterfront kill. There's 15 dead eels in 2019 between Swanton and Milton.
Okay, so he's referring to the eel die-off. Yeah, I do remember being not caught, but I remember being involved in an email discussion of what was going on with eels that year. And we really, the honest answer is we really don't know, and I don't know if anybody ever figured it out. But it was very, very suspicious that, you know, it was just this particular species that was running into trouble, and we couldn't figure out exactly why. And if I remember correctly, and I may be wrong about this, but I think it was coming in the late part of the summer as we were moving towards fall. And Matt, you can correct me if I'm wrong about that. And one of the ideas that I had, and again, it's really just speculation, is that we know that some time ago, as I mentioned in my talk, folks in Quebec brought elvers in from the coast, put them into the Richelieu in the hope that they would start repopulating eels in Lake Champlain. But of course, we know that eels don't reproduce in Lake Champlain. They don't reproduce in fresh water at all. But the hope was to try to get enough of these eels into Lake Champlain that they might start another run, so that when they go out through the Richelieu, you know, maybe they could get things going back out all the way out to the Sargasso Sea. I was wondering, and again, this is just wondering, if maybe some of those eels had gotten to a point in their lives where they were supposed to migrate, but they didn't know how. They just, because they had never literally gone through the process of finding their way into Lake Champlain, maybe they just couldn't find their way back out of Lake Champlain. Now, that is complete speculation, because we don't know how eels find their way back out of Lake Champlain. Does it depend on their ability to get into Champlain, and can they retrace those steps the way salmon do? And I honestly don't know the answer to that, but there was some speculation that might have had something to do with it. There was a completely alternative explanation, which is probably more realistic, which was there were problems in other places with eels that year because of a parasite. I don't remember the name of the parasite, but it was a parasite that affected the gas bladder, and the fish would lose their equilibrium and they couldn't manage anymore. So it may have had absolutely nothing to do with migration. It may have just been a parasitic infection that happened to affect, 15 or 20 eels in the area. So all at once, because it's not like it was something that happened frequently. I mean, I remember talking to some of the biologists about it, and it wasn't unusual to get a couple of eels once in a while showing up, but dead. But to have that many all at one time seemed really, really unusual.
Yeah, thanks. Matt is commenting. He said that, speculation indeed is roundworm. So that's the event that he was referring to. Well, I'm mindful of your time, Doug. I'll finish things off by Lauren. Lauren has a suggestion that next time we can talk about the host-parasite relationship between native fish and native mussels. So maybe that's our topic for next time.
The host parasite, the fact that mussels rely on fish to distribute their young and things like that. Yeah, that would be an interesting. I have to admit, I would have to do a lot of research on my mussel biology to know which ones do and which ones don't rely on fishes as a mechanism of transport, but and distribution. But it's never, you're never too old to learn new things, so.
Well, it's a fascinating topic, and we'll hit it eventually. Thanks for the request, Lauren. Doug, thanks so much. We'll let you get to dinner or wherever else you have to be this evening. Thanks, everybody. Be well, have a good rest of your week, good weekend, and hope you enjoy exploring the waters here in the year to come.